Hey guys, today we're going to go through 9.3, which is the unit circle. I did want to split this up just because it is another bigger set of notes into two separate videos. So for this first video, I'm going to be going through just kind of introducing what the unit circle is, and then taking a look at the first three examples. So how like the unit circle interacts with a 45-degree angle, 30 degrees, and then 60 degrees. And then that's going to be it for this video. And then I'll post a second one that's going to just be this extension, which will help you a lot, because tonight the only homework you have is to be completing the unit circle. So that blank unit circle is what your homework is going to be, and that extension will help you a lot with getting the rest of that filled in. So, like we talked about last week, in 9.2, when we started talking about radians and everything, we talked about putting an angle in standard position. So just a quick recap on that. I stay in standard position. The angle has its vertex at the origin, so at 0, 0. And again, that picture over to the left is an angle in standard form. You can see again the vertex is at the origin, so it's at 0, 0. The initial side, which also could be called the initial ray, is on the positive x-axis. So again, always that right side of my coordinate plane. And then obviously the terminal side would be somewhere along anywhere else in the coordinate plane. But again, that vertex is at the origin, and that's going to go off into wherever direction it wants to. So what we're talking about today, with kind of extending that beyond, we're going to be talking about something called the unit circle, which the unit circle, as it sounds, is a set of points that are all 1 unit away from the origin. They're all 1 unit away from the origin, which means since it's at the origin, its center is at 0, 0, and the radius of that circle, if all those points around the outside of it are 1 unit wide, the radius of that circle would be 1. And we're going to be taking a look at kind of how our different angles interact with that circle. So what we're going to be doing is splitting this up into our 3 special angles. So if you remember way back in 9.1, we talked about those 3 special right triangles, our 2 special right triangles with those 3 special angles, our 30, 60, 90s, and then our 45, 45, 90s. So in those right triangles, we had those shortcuts that we developed, where we looked at if we knew one side of my right triangle, we could find the hypotenuse, or vice versa. Same thing with my 30, 60, 90. If I knew the short leg, I could find the long leg and the hypotenuse, or vice versa. So we're going to be using those specific angles in what we're talking about today. So what we're going to look at first is a 45-degree angle. So if we plotted a 45-degree angle here in my unit circle, or on my unit circle, it would be somewhere, let's change to blue. It would be somewhere around here, maybe not quite. And actually, I'm going to try and make it a straight line. I'm going to lock in place there. Just about there. Not perfect, but close enough. That would be a 45-degree angle. Now, in a unit circle, since it is 1 unit, all the points on my graph are 1 unit away from the origin, we know that radius is just positive 1. Now, to find the other parts of this, what I'm going to be doing here, I'm actually going to drop a perpendicular to make a little right triangle in my graph. So that's something a little bit more manageable for what we're used to seeing. I'm going to make that so it's a straight up and down instead of angled like that. Because what I've done here is made a little 45, 45, 90 triangle. Now, if you remember, for a 45, 45, 90, I'm going to do that scratch work over here. Lock it into place. There we go. Close enough. So in a 45, 45, 90, if we knew what our 2 sides were, like that, there we go, then my hypotenuse was just x times the square root of 2. So if I was trying to work backwards, if I knew what my hypotenuse was, and I was trying to find out what my legs were, which is the case here, we're trying to find what that vertical dotted line is, or what that horizontal is, because I'm working off of these questions over here. We found the length of the hypotenuse, that was 1. The length of the legs that we're trying to figure out now. So if we know that x root 2 is equal to 1, that'll let us solve for what x is, which would be the 2 legs of my right triangle. So in this case, I have to divide by the square root of 2 on both sides, and x is 1 over the square root of 2. But we can't leave it in that form. I have to make sure that I have everything rationalized. So I'm going to have to multiply by the square root of 2 on top and bottom. And what I end up with is the square root of 2 over 2. And that's what the length of each of my 2 legs are. Because again, that was using that to solve for x. Now in my right triangle now, if I was able to label these, well, this is square root of 2 over 2. This is also the square root of 2 over 2. What that lets us do, as soon as we know what those 2 legs are, it lets us find this thing called the terminal point. So I'm going to switch to red here. So this point right here on my unit circle, which is where a 45-degree angle hits the actual circle. We could figure out the coordinate of that by just looking at the 2 legs of my right triangle. I know in this case that my x value of that point is how far left or right I moved. So in this case, I moved to the right the square root of 2 over 2. So the x value is going to be the square root of 2 over 2. And kind of the same idea for my height. I went up the square root of 2 over 2, so that's going to be my y value, square root of 2 over 2. So that would be my coordinate. That's the coordinates of a 45-degree angle on the unit circle. Now, where this is useful, and kind of the reason that we're studying these unit circles, or this unit circle, these angles in the unit circle, is because if we look at evaluating like sine or cosine, what ends up happening if we looked at, let's switch over to something different. So let's do green. If I wanted to do, let's just say the sine of 45 degrees, and we'll just use this as an example. This right triangle here. Let's just assume, well, it doesn't really matter because with trig it all reduces. But for this 45-degree angle here, if I was going to find the sine of that angle from this 45 degrees, my opposite would be right here, my hypotenuse would be right there. Because sine, so, in SOHCAHTOA, is opposite, square root of 2 over 2, all over my hypotenuse, which is 1. So I end up with the square root of 2 over 2. Which, in this case, it's a little unclear to see, but that's going to correlate to this y value for my coordinate, my terminal point. Because again, that height is the opposite that I was looking at. And if I was looking for the cosine, it would be this adjacent side over the hypotenuse, which in this case is 1, which is always going to be the case for a unit circle. So the x value for my coordinate, my terminal point, is going to be the cosine. It'll be a little bit more clear when we have one with our 30 degrees or my 60 degrees that have 2 different values, because here both my x and my y are the exact same value for my coordinates. But what this is basically it's going to be a shortcut for us to know what sine and cosine are, and eventually the other 4 trig functions with tangent, cosecant, secant, and cotangent. But that's for a 45-degree angle. Square root of 2 over 2, comma, square root of 2 over 2 is that terminal point. Okay? So, continuing on to example 2, for a 30-degree angle, we're going to be doing the same thing. So we're going to go ahead and draw in our 30-degree angle. We're going to drop a perpendicular to make a right triangle in our unit circle, and then kind of work our way around. So let's start with that same first step. Let's look at a 30-degree angle in our unit circle. So 30 degrees, I'm going to go about a third. That looks about right. Probably not perfect, but that's okay. Drop my perpendicular. So now this is 30 degrees. That is still 1 because it's still the radius of the circle, and it's a unit circle by definition. It's still 1. So now I'm trying to figure out the two sides of the two legs of my right triangle. And in a 30, 60, 90, I'm going to let that lock in place. So my 30, 60, 90, my short leg, I have that drawn backwards. That should be switched around. 30 is the small angle. That should be 60. That should be 30. There we go. So X is my short leg in this case. That's what everything else is based off of. So if I know what my short leg is, my hypotenuse is just double what that is. And then my long leg is my short leg times the square root of 3. So if I knew, in this case, if I know what my hypotenuse is, my short leg is half of that, which in this case, my hypotenuse is 1. So that tells me that my short leg, which is this dotted line here, is a half. I don't like that. Let's move it over a little bit. Is a half. All right, because half of my hypotenuse is my short leg. And then my long leg is the short leg times the square root of 3. So a half times the square root of 3 is just the square root of 3 over 2. So now I've got all three sides of that little right triangle. So if I'm trying to figure out the coordinates of that point, switch to red again, now it's a little bit different. It does make a difference. My x value is how far to the right I moved, which in this case I moved over the square root of 3 over 2. And my y value of that coordinate point is the height of that right triangle, so in this case, a half. So that would be my coordinate. That would be my terminal point for a 30-degree angle. And again, now, if we try and take a look at with this one, I think it'll help make it a little bit more clear how this ends up working. So if I wanted to try and find, let's just say, let's start with sine again, the sine of 30 degrees. If I was going to use this triangle, so there's my opposite, my adjacent, my hypotenuse from 30. So the sine of 30 degrees would be the opposite side, in this case, a half, over my hypotenuse, which is always just 1 in my unit circle. So that tells me that the sine of 30 degrees is a half. If I want to do cosine of 30 degrees would be the adjacent, square root of 3 over 2, over my hypotenuse, which is just 1. So I end up with the square root of 3 over 2. So what ends up happening, if you look, the sine of my angle is the same thing as the y value of its terminal point. And the cosine of my angle is the same thing as the x value of that terminal point. So once we go through and develop this, which is going to take a little while at first, but then once we've gone through and done this the first time, you'll have that unit circle completely filled in with all of the angles all the way around. You won't have to have those memorized. You're just going to have the sine, cosine values of all of those angles. And then we'll also work after that on going through and talking about how we can use those to find other angles as well. Okay, so that's the benefit of the unit circle. That's where those things come into play. So then for our last one, which is our 60-degree angle, is going to look very similar. Really what ends up happening with this, since a 60-degree angle, which let's go ahead and draw first. That's going to need to be more like that-ish. Oh no, it didn't go all the way. Let's try that again. There, just about there, good enough. Now we're going to drop our perpendicular, right angle. Now this is a 60-degree angle. So that's still a hypotenuse of 1. It's still a 30, 60, 90 triangle with a hypotenuse of 1. So really, I'm still doing the same. I still have the same two other sides. It's just that here, my short leg, which is still a half, is down below. It's the horizontal piece. And then that square root of 3 over 2 ends up being the vertical part of that triangle. But it's still the same side length, because it's still a 30, 60, 90. So when we go through and do this, all that changes is that now the x value of my vertex, of my terminal point, ends up being a half, and the y value ends up being the square root of 3 over 2, because, again, my dimensions are changing. Now I'm going to the right a half, so that's my x value, and then I'm going up the square root of 3 over 2, so that's my y value. So that's how I get my terminal point. And again, if you want to do a quick little show you on where that's beneficial, if we look now at our 60-degree angle, and we're trying to evaluate, trying to evaluate with it. If I was trying to find the sine of 60 degrees, that would be the opposite, square root of 3 over 2, over the adjacent, which is 1. So I end up with the sine of 60 is the square root of 3 over 2, which still ends up being the y value of my terminal point. So sine is always the y value, cosine is always the x. I could show you cosine, but it's going to be the same thing. It's going to end up coming out as positive 1/2. So that's going to be it for this first video. The second video that I'll put out is going to go through the extension part of this, where once we've developed, or now that we've gone through and identified the first quadrant in our unit circle, we've got our 30, our 45, and our 60-degree angle. Then we'll go through and kind of use that to find the other parts of my unit circle around the other 3 quadrants, and then kind of get into our actual unit circle.